ChatGPT Face ID self-driving cars, fraud detection in 100 milliseconds, medical scans flagged before a doctor looks. Every one of these runs on the same technology, deep learning. The deep learning market hit $64.92 billion in 2026. Worldwide AI spending is expected to reach $2.5 trillion this year, and the vast majority is built on deep learning foundations. It is no longer a research curiosity. It is the engine underneath virtually every AI product you use. Here's how it actually works. A neural network is layers of artificial neurons, loosely inspired by the human brain. Data enters the input layer, pixels, words, numbers. Hidden layers transform it step by step, learning increasingly complex patterns. The output layer delivers the result, a classification or a prediction. The network learns through training. It makes predictions, measures how wrong it was, and adjusts the connection strengths through backpropagation. Deep learning figures out which features matter on its own. No human engineer telling it what to look for. That's why it dominates complex data. Deep learning isn't one architecture, it's 5. CNN's convolutional neural networks dominate image and video processing, powering Face ID and medical imaging. RNNs and LSTMs handle sequential data like time series and fraud detection. They maintain memory of what came before, processing data one step at a time. Transformers are the architecture behind ChatGPT and Claude. They use self-attention to consider every word in a sentence simultaneously. GANs pit two networks against each other to create synthetic content. Diffusion models generate images from text prompts, replacing GANs for creative AI in financial services. Deep learning models score fraud probability on hundreds of transaction features in under 100 milliseconds. McKinsey found organizations deploying generative AI reported 20 to 40% productivity improvements. CNN Vision Systems inspect units with 99% accuracy. Now, 5 structural limitations every decision maker must understand. 1. Deep learning is data hungry. 2. It's computationally expensive. 3. Deep learning models are black boxes. Only 20% of practitioners believe their models are fully interpretable, creating compliance problems. 4. Models don't generalize beyond training data. 5. Deep learning is not reasoning. It is sophisticated pattern matching, leading to hallucinations. Deep learning earns its investment when working with unstructured data at scale. Most organizations access it through fine-tuned APIs and managed cloud platforms. The organizations succeeding with it in 2026 aren't treating it as magic. Start with the problem. Match the architecture. Deploy deliberately. Full guide is linked in the description. Like the video and subscribe to the AI Buzz. It really helps us grow.